Welcome to The Explainer, where we break down big topics into clear, understandable pieces. Today, we're diving into a core concept that powers so much of the software we use every single day: software reuse. So here's our game plan. We'll kick things off by talking about why we even need this in the first place. Then, we'll explore the 4 different levels of reuse, see how it actually works in the real world, do a little reality check on the pros and cons, and finally, talk about why this is such a fundamental shift in how we think about engineering.
Okay, let's just dive right in. We all kind of know that building software from the ground up is, well, incredibly difficult. It's complex and it is definitely expensive.
And what's really wild is that the cost to just maintain a piece of software over its lifetime, it can be several times more than the initial cost to build it. That's a huge problem, and it makes finding smarter, more cost-effective ways to build things absolutely essential.
And that is exactly where software reuse comes into the picture. It's really all about creating new systems using pieces that already exist instead of starting from zero every single time. It's a key discipline for building really high-quality, reliable systems without breaking the bank or taking forever.
So does that just mean this is a fancy term for, copying and pasting code?
Not at all, actually. It's way more structured and sophisticated than that. It really operates on 4 distinct levels. At the very top, you have the abstraction level. Think of this like reusing a successful blueprint or a proven design. Then you have the object level, where you're pulling in a specific thing, like a pre-built calendar widget from a library. Below that is the component level, where you're using whole collections of objects that are already built to work together. And then the big one, the system level, where you might be reusing an entire application as part of an even bigger system.
That all makes sense conceptually, but how do developers actually put this into practice on a real project? What does that look like?
Well, it follows a formal process that really flips traditional development on its head. You start by figuring out what you need, but then, instead of just starting to design from scratch, developers go into a discovery phase to hunt for reusable components. And here's the key: they might actually tweak the original requirements based on what they find out there. From that point on, it becomes a process of assembling the puzzle, configuring, adapting, and integrating all those pre-built parts.
This sounds incredibly efficient. Honestly, it almost seems a little too good to be true. So what's the catch?
You're right to be skeptical, because there is definitely a trade-off. The upside is huge, right? Lower costs, less risk, because you're using tested code, and faster delivery. But the price you pay is a loss of control. You might have to compromise on exactly what you wanted to fit in an available component, and you become dependent on the original creator for things like updates and security patches.
And yeah, reduced cost for sure doesn't mean no cost. There are very real costs you have to factor in. First, just the time it takes to search for and evaluate components. Then there's the actual price tag if it's commercial software. And that's all before you get to the cost of adapting, configuring, and making sure all these different pieces actually work together seamlessly. So, okay, even with all those challenges, it seems like software reuse isn't just some niche strategy. It's a pretty fundamental part of how we build software now. It's more than a big deal. It's become the dominant way we build things, especially the complex web-based systems we all rely on every day. Honestly, assembling systems from pre-existing components, a lot of them from the huge world of open-source libraries, that is modern software engineering.
And that's really the crucial takeaway here. Software reuse changes the very nature of what it means to be a developer. It marks this massive shift from being a craftsman who builds every single piece from scratch to being an engineer who intelligently selects and assembles proven parts to create something new and powerful. Which brings us to a really big question for the future of the whole industry, right? As we move forward, is the most valuable skill for a developer going to be the ability to create brand new code, or will it be the ability to find, combine, and curate existing code in novel ways? It's a fascinating shift to think about.